is 3I Atlas, the interstellar comet now passing through our solar system. An alien artifact? No, probably not. But the story is still worth telling. While we often talk about space, time, and the far future, this one feels personal, because every so often, something from beyond the stars slips quietly into our backyard and reminds us how small we really are. Back in 2017, we found the first one, 1I Oumuamua. It looked nothing like anything we'd ever seen. Then came 2I Borisov in 2019, and now, in 2025, we meet the third, 3I Atlas. A visitor with a story written in ice and sunlight. It was first spotted on July 1st, 2025, by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a network of telescopes built to watch for potential threats to Earth. Instead of danger, they found wonder, an object that didn't belong to our solar neighborhood at all. Its technical name is C2025N1, Atlas. The C meaning Comet, 2025N1, marking it as the first found in the second half of July, and Atlas honoring the survey that discovered it. But since it isn't bound to the sun, astronomers gave it another title, 3I Atlas. The I means interstellar, only the third ever confirmed. But what truly made 3I Atlas different was that it came alive. Almost immediately after discovery, it began to glow. A halo of gas and dust blooming around it, forming the unmistakable tail of a comet, and this happened far from the sun. Over 3 times Earth's orbital distance away. That shouldn't happen, not unless it carries ices more volatile than water. The kind that vaporize in the deep cold of space. Its path is hyperbolic. A one-way ticket. 3I Atlas will swing close to the sun on October 29th, 2025, giving Earth its closest look in December, and then it will vanish forever into the dark between stars. We'll never see it again. One pass, one chance. I'd normally wait until all the data is in before talking about something like this. But this one deserves more than numbers. Because every time we spot a wanderer from beyond, the same question returns. Could it be alive in another way? Could something, or someone, have built it? The honest answer is probably not. Yet, this is also the perfect moment to imagine what's possible. To ask whether one day we might do the same. Whether humanity could someday hijack a comet or asteroid, hollow it out, and turn it into a starship, the kind of vessel that sails not on fuel, but on physics. Because in a sense, that's what comets already are, ancient messengers. They travel on long, stretched ellipses, sometimes nearly circular, sometimes impossibly thin, diving toward the sun, shedding dust and light before retreating back to the deep. Each pass carves away part of them until nothing remains. And yet, through gravity, through chemistry, through the slow erosion of eons, they move like whispers of creation itself. Every orbit changes them. Every encounter reshapes their fate. And for a few, rare ones like 3I Atlas, their paths are no longer ellipses but hyperbolas. Curves that mean freedom. They're not coming back. They never belonged here to begin with, and maybe that's the real wonder. Not that it might be alien, but that we are able to notice it at all. A frozen traveler from another sun, drifting past our own for the briefest cosmic moment before it disappears again into the dark. When a comet crosses the sky, we tend to think of it as a wandering relic. A frozen whisper from the birth of a solar system. But sometimes, that whisper carries a question so bold it feels almost human. Could it be a ship? Let's start with the physics. a star's true domain. The region where its gravity reigns stretches for light years, but only a tiny fraction of that space is bright enough to feel its warmth. A passing interstellar spacecraft, moving fast between the stars, would almost certainly aim for a star's inner zone. Not to visit, but to borrow, to steal speed, to use gravity the way a surfer rides a wave. That's what makes the spaceship theory of interstellar comets so fascinating. Because, on paper, it actually makes sense. When astronomers confirmed that 3I Atlas was moving along a hyperbolic trajectory, it meant one thing for sure: it wasn't staying. But that alone doesn't prove it came from another star. Ordinary comets can sometimes be flung out of our solar system after a close pass with Jupiter or Saturn. Yet, after plotting Atlas's path, nothing suggested such a planetary slingshot. No gravitational kick, no local origin. It came from somewhere else. That makes it alien. Not in the science fiction sense, but in the literal one, foreign. Maybe it's not piloted by bug-eyed explorers. Maybe it's just a shard of ice and dust, torn from its home system and cast adrift for eons. Still, it carries secrets. Hints of alien chemistry, alien worlds, alien histories, and as it blazes through our skies, it reignites a question we can't help but ask. What if it's more than a comet? Could it be a spaceship? If you ever wanted to cross the stars on a budget, a comet would be a clever place to start. It already has everything you'd need. Thick layers of rock and ice to shield against radiation, water and gas to recycle into air or fuel, a solid frame to build inside. Hollow out the core, build habitats, bolt on engines. And you've got yourself an interstellar arc disguised as an ordinary comet. Even without engines, there's another trick: gravitational assists. We've been using them for decades. Voyager, New Horizons. Each gained free speed by swinging around planets, borrowing a little momentum each time. And if you time it right, firing your engines when you're moving fastest near the planet, you get a massive boost from what's called the Oberth effect. Imagine this: you fall toward a planet, gravity pulling you faster and faster. At the bottom of the dive, you ignite your engines. You'd get far more energy from that same burn than you ever could in deep space. It's like catching a tailwind at the perfect second. The cosmos itself helping you accelerate. Now, that's exactly the kind of path 3I Atlas is taking. Diving toward our sun before slinging back into the dark. And that's why, for some people, the thought lingers. What if it isn't a comet at all, but a ship using the same tricks we would? But is it likely? Here's the honest answer: not really. We see no sign of control, no unusual signals, no structure that breaks the laws of physics, nothing behaving in a way nature can't explain. And if you were an engineer building a starship, you wouldn't design it like a comet, with its surface covered in volatile ices that boil off unpredictably and wastefully into space. You'd seal it. You'd channel every bit of that fuel into directed thrust, not random vapor trails. You'd probably unfurl huge solar sails to harvest light and use radiation pressure to maneuver with grace. In short, you'd build smarter. So, yes, a comet could, in theory, be a spaceship. The concept works. But 3I Atlas, it's almost certainly just what it appears to be. A breathtaking traveler from another sun, here for one brief visit before vanishing forever into the dark. And maybe that's enough. Because sometimes the mystery itself, that fleeting thought that maybe, just maybe, is what keeps us looking up. Maybe the ship is broken. That thought always comes up when we talk about the Fermi paradox. That haunting question of why, in a galaxy full of stars, no one seems to be calling back. But when an explanation depends on something being broken, we step into uncertain territory. Because if alien technology ever existed, ancient, drifting, forgotten, we should expect signs, not just one, but many. Every civilization leaves a trail. A single beacon or flash of light might catch our attention first, but real technology comes with a chorus of fingerprints. Heat, waste, signals, architecture, pattern. From orbit, even a quiet human city hums with hundreds of technosignatures, streetlights, radio waves, warmth against the cold. And even when those cities die, they don't disappear, they fade, but the bones remain. Rusted hinges, broken glass, faint outlines in the dirt. A porch light might be the first thing you notice, but when you get closer, you see the truth. This was once alive with thought. Right now, I'm sitting in a cabin in the hills of Kentucky. My wife and kids asleep, the porch light humming, a laptop open when it shouldn't be. Vacations never work for me, writing does. On the drive here, we passed an abandoned trailer, a collapsed shed, the ghost of a home that once was. Even in ruin, they told a story. Gravel still marking a driveway, shards of glass catching the morning sun, a soda can half buried in the grass. That's what technosignatures are, not proof, but memory. And if something out there truly was technological, it wouldn't hide perfectly. It would come bundled with hints. Some faint, some obvious, all pointing toward intelligence. So far, 3i Atlas hasn't shown any, no hidden signals, no patterns that defy nature, but it does have its quirks. The kind that make astronomers pause and look twice. Chemically, 3i Atlas is strange. It's coma. That glowing cloud of vaporized gas and dust is ruled by carbon dioxide. CO2 outnumbers water vapor nearly 8-to-1, an imbalance that tells us it was likely born far from its parent star, in a place so cold that water froze solid while carbon dioxide stayed free. Then there's the light. When sunlight scatters off a comet's dust, it becomes polarized. Its waves aligned in certain directions. For most comets, that pattern is predictable. A shallow dip in polarization at small angles, then a flip as the comet swings away from the sun. But with 3i Atlas, the pattern bends sharply. Deeper, narrower, stranger. The light doesn't behave like it should. That suggests its dust grains are built differently, fluffier, more porous, maybe coated in materials we've never seen before, tiny, microscopic crystals. The dust of another world, reflecting light in ways that betray where they were born. This isn't just academic trivia. For astronomers, polarization is a window into the unseen. A way to read the texture of alien geology from millions of miles away, and through that light, we catch a glimpse of something profoundly foreign, a piece of another solar system, carrying the fingerprints of its home star. 3i Atlas also came alive earlier than it should have, even while it was more than 3 astronomical units from the Sun. Farther than the orbit of Ceres, traces of water vapor appeared. That shouldn't happen. Comets usually stay dormant until they cross the frost line, where sunlight can melt ice into vapor. But this one started before the warmth could reach it. Maybe that's what makes it so beautiful. And so humbling, because in every faint vapor trail, every polarized beam of light, there's a message written in chemistry, not words, that even the smallest traveler from another star can remind us how vast and alive this universe really is. The best guess right now is simple. 3I Atlas might have large icy grains in its coma that evaporate slowly. Or maybe it has a few active vents on its surface releasing gas unevenly. That's it. And here's the thing. When scientists say, "We're not sure why," it doesn't mean something is strange or artificial. It means the universe is being itself. Unpredictable, complex, but not necessarily designed. In fact, if anything, the early loss of material from this comet argues against the idea that it's a spacecraft. You wouldn't want your ship bleeding mass at random unless that mass was propellant. And this isn't propellant, it's just ice turning into vapor. It also makes the object brighter, easier to spot. That alone would make it a terrible design for a stealth probe. Then there's the orbit. It's retrograde, moving opposite the general spin of our solar system, but still aligned within 5 degrees of the ecliptic plane. That's odd. Most objects that share our plane do so because they were born from the same ancient disk of dust and gas that built the planets. A visitor from beyond should come from any random direction. Only a few % would ever line up so neatly with our own. So yes, the odds are small. Roughly 3%. Unusual, but not miraculous. Sometimes randomness just draws a straight line through the noise. And that's a quiet reminder. Even cosmic coincidences can look familiar when they pass close enough. None of these features scream alien artifact. They whisper what we already know. That the universe is endlessly creative. A comet from another star should be unusual. That's the point. It carries the signature of a chemistry foreign to our own skies. And yet, talking about this kind of thing always pulls me into reflection. We often imagine humanity's future among the stars. Centuries ahead, entire civilizations sailing between suns. But how often do we stop and think about what defines the society we already have? Our world is built around a simple number, 100 years, a human lifetime. Our schools, our careers, our families. All time to fit inside that narrow frame. Change that number, and everything changes. Imagine what happens when time itself, the rarest resource in the universe, stops running out. So, why isn't it a probe? Because a probe implies intention, navigation systems, instruments, control, purpose. None of that is visible here. If someone or something built this to observe us, it's doing a terrible job hiding. That glowing tail is a cosmic flare, not camouflage. If the builders wanted to be seen, we'd expect movement. Maybe a flare of radio signals, or a massive solar sail unfolding like a flag against the sun. We've seen none of that. The only other explanations? They didn't care who saw it. They didn't expect anyone to be watching. Or whatever systems once existed are long gone. Broken, silent, forgotten. But that seems unlikely. Any civilization capable of interstellar travel would know the risks of being noticed. They'd plan for that. And besides, you wouldn't need to send a massive machine across light years to discover Earth has life. Our biosignatures have been glowing in the dark for billions of years. Could a civilization broadcast a message through something like a comet tail? A brilliant, visible plume of light and dust? Absolutely. It would be a stunning way to make a statement. A cosmic billboard written in vapor, but that's not what 3I Atlas is doing. Its brightness, its unpredictable jets, its shifting path, all follow the laws of ordinary cometary physics. Ice swarms, gas escapes, the tail flickers. Nature, not technology. If it were a probe, we'd see control. deliberate thrust, stable patterns, signs of engineering. Instead, we see chaos, beautiful, natural chaos, the kind the universe has always known how to make. And maybe that's the wonder of it. Not that it's alien technology, but that it's alien nature, visiting us just long enough to remind us how alive the cosmos truly is. A true probe would guard its mass and power like treasure. It would conserve every ounce, every watt, every molecule. But 3I Atlas does the opposite. It's shedding its ices freely, glowing brighter the closer it gets to the sun. Wasteful, loud, and impossible to hide. That makes sense for a comet, but not for a scout trying to slip quietly through the dark. We still don't know exactly how heavy this thing is. On the low end, it might weigh around 10 megatons. The mass of 100 aircraft carriers. On the high end, it could be 100,000 megatons, 1,000,000 carriers. An almost unimaginable giant. If that's a probe, it's a wildly inefficient one. Our own robotic explorers weigh a few tons at most. 10, maybe 20, not millions. And if someone had the ability to launch a probe that massive, it's hard to believe it would be limping through space, half broken. Efficiency alone tells the story. If you wanted to study a planet, you'd build something smaller, lighter, faster. A telescope that could stay still and watch from afar, not a mountain of ice tumbling between stars. Now, it's true. You don't always want your flyby probes moving too fast. High speeds cut short your chance to observe. But if this were truly designed, it could have planned a smarter path. Using gravity to slow itself down instead of racing by, it could have arranged to pass by Jupiter or Saturn, shedding velocity with a perfect slingshot. The timing would only add a few years. Nothing compared to a journey lasting thousands. Instead, 3I Atlas shows up on a clean hyperbolic orbit, untouched by any giant planet, traveling straight through our system and back out into the void. That's why we know it's interstellar. Not a clever disguise, not a mission, just a traveler from somewhere else. If this were a true probe, it wouldn't come alone. We'd expect a chorus of technosignatures, radio whispers, optical flashes, strange heat signatures, patterns that don't belong to nature. We've found none. No radio, no infrared glow, no engineered reflections or steady pulses of light. The silence isn't proof, but it's telling. Everything we see, the mass loss, the brightness, the chaotic jets of vapor, all point to something natural, not built, born. Even if 3I Atlas isn't a spaceship, it matters more than we might think. Every interstellar visitor is a sample, a free gift from another sun. We can't yet travel to other star systems, but sometimes their debris drifts to us, and with it, the chance to study alien chemistry directly, the ices, gases, and dust that once circled another star billions of years ago. Is water always the main ingredient? Or do some worlds form richer in carbon dioxide, methane, or exotic frozen gases? Are dust grains always compact and solid, or can they be soft and fragile, like the porous clusters 3I Atlas seems to carry? Each visitor adds one more clue, one more sentence in the story the galaxy is trying to tell. And as we ask what makes this comet natural, we also end up asking something bigger. What would we build if we ever sent probes into the unknown? Would we hide them? Would we make them resemble comets, the way nature already does? We've imagined that future before. Turning asteroids into interstellar ships, crafting engines inside mountains of rock and ice. But 3I Atlas isn't one of those. It's almost certainly just what it appears to be, a frozen fragment of another world. wandering through ours for the briefest moment. And yet, in its passing, it reminds us of something profound. That the galaxy is full of stories written not in ink, but in dust and light. Stories waiting for us to learn how to read them, and maybe, one day, to write our own.